Hello. Right. Okay. This is a question in the biological molecules question booklet on enzymes. It's question number 9, and it begins like this. Okay. Amylase is an enzyme. It catalyzes the reaction starch to maltose. Okay. Students mixed a starch solution with amylase. They recorded the concentration of maltose at intervals for 20 minutes. Figure 1 shows their results. So firstly, any question about enzymes, really important to identify what is the substrate and what is the product. So here, starch being the substrate, maltose being the product. Okay. The enzyme amylase. And amylase must have an active site which is complementary to starch. And then if we have a look at the graph, really important as well whenever we look at a graph to consider the x and the y axes. So on the x-axis we have time, and on the y-axis the concentration of maltose, or as we've already discussed, that is the concentration of the product. Okay. The reaction was the rate of reaction was lower after 10 minutes than it was at 5 minutes. Okay, so we can see the rate is actually on this graph is shown by the gradient, and the gradient is steeper at 5 minutes than it is at 10 minutes. Okay. Explain why then the rate of reaction was lower at 10 minutes. So, going back to what we just said. The students were recording the concentration of maltose. That means they're recording the concentration of the product, and the concentration of the product increases over time. As the product increases, that means the substrate concentration must be decreasing, and that's the key to this question. So, explaining why, well, the concentration of the substrate or starch decreases, and therefore if there is a lower concentration of the substrate, there will be fewer enzyme substrate complexes forming. There will be fewer enzyme substrate complexes forming in any given time, and therefore if there are fewer enzyme substrate complexes forming, the rate will be lower. Okay, next question then. Explain why there is no further increase in maltose concentration between 15 and 20 minutes. So we can see here, if we look at 15 minutes on the graph, and then 20 minutes, at this stage the graph has plateaued. So we've already described or explained in 9.1 that the concentration of the starch is decreasing. Now there's no further product being formed here, and the reason for that is because there's no more starch to react. So all the starch, which is all of the substrate, has been converted to maltose, which is a product. The first mark. So if there is no more substrate, no more starch, there can be no more enzyme substrate complexes forming. So no more. Now I'm going to call this ES complexes for now because I'm lazy. But in your exam, obviously, you must give the full enzyme substrate complexes. So no more enzyme substrate complexes can form, or another way of saying that is there are no more reactions possible. Okay, so this just extends that concept that over time the substrate is converted into product. Eventually all of that substrate will be gone, no more substrate, and therefore there can be no more enzyme substrate complexes. Okay, give one variable that the student should have kept constant in this experiment. Okay, well these variables are those variables that will have an effect on the rate of an enzyme controlled reaction, such as the temperature, the pH, the concentration of the substrate, and also the concentration of the enzyme. Okay. Again, abbreviations not acceptable. I'm just being a bit lazy. Like and temperature is one of those. You can't just abbreviate to temp. You will not get the mark. Okay. Lastly, then, it says use the graph to calculate the rate of maltose formation in grams per decimeters per minute over the first 15 minutes. So it wants to know during this period from 0 to 15. Okay, and we can see if you must use a ruler at this stage, but I used a ruler earlier on, and that will be 10 grams per decimeters cubed over 15. So we need to use the equation. So it's the change in the y over the change in x, and therefore that is 0 to 10 over the change in x, the time, 15, which will equal 0.66 blah 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 7. I'm just going to do it 3 decimal places there, or to do 2 decimal places in there. So 0.667 or 0.67. Okay, just to reiterate the really important parts of this question to help you answer all of the parts. On the graph, it shows a concentration of the product. If we're measuring the concentration of the product, and the product increases, we must know that the substrate is decreasing. Until eventually all of that substrate has been used up, so no more enzyme substrate complexes can be formed. This phrase, enzyme substrate complexes, should be included in any explanation of the rate at which enzymes are working. If more enzyme substrate complexes form, the reaction increases in rate. If fewer form, the reaction decreases in rate. And then I think that's everything. Okay, I hope that was helpful. Cheers.